Yeah, good morning, students. In the last class, we were discussed about the course objective 7, that is, apply the concept of engineering fundamentals in civil engineering, mechanical engineering, electrical and computer engineering. So we were started with the civil engineering in the last class, so that we will continue the same. So I hope we have discussed about the basics and applications and role of civil engineer, various branches in civil engineering. All those things we already discussed. We have discussed about the functions of civil engineering also. So this structural number forces, which is very important. These basics are required for all branches of engineering. Not only for civil, it requires for all branches. And we were discussed about this. So hope in the last class we have left from the types of bridges, 6 bridges. In that we have already discussed the beam bridge. So this is nothing but a beam bridge, and truss bridges to evenly distribute the loads between the two structures, and suspension bridges with cables and other arrangements where the load can be distributed. So this is the latest bridges which attracts more countries. And another is arc bridge. So this one is arc bridge, which we have left here. In the arc bridge works by transferring the weight of a bridge and its loads partially into the horizontal thrust retained by the abutments at either side, right? So that is the basic principle behind your arc bridge. And cantilever bridges. So the cantilever bridge is built using a cantilever structures that project horizontally into space, supported on only one end. So you can see here, this is the cantilever bridge arrangements. There is only one support on both sides. There will be a projections, and this part will act as a cantilever, and this is another cantilever, and this will be considered as cantilever bridges. Cable stayed bridges. So this can be used as an temporary bridges. Cable stayed bridges. One more towels from which cable support the bridge heads. So here, sorry, this is not a temporary bridge arrangement. It is similar to your previous one. This is almost similar to the counter of this one, suspension bridges. So it will be counter for suspension bridges, which will be called cable bridges. So this support horizontally increased to a certain extent, and this part of the weights is supported by this cables, and likewise both sides. Just a minute. These are the general thumb rule to design with the stresses. So hope this I will explain in the later days. So now we will pass over to the skyscrapers. Skyscrapers are very tall buildings with many floors. That is nothing but skyscrapers, and simply a multi-story building. Campus have been a fascination of for people. For engineers, it's a challenge to build structure that rises hundreds of feet above the ground. So not as 20 feet or 30 feet, it is around 100 feet and more than that. The Great Pyramid of Giza built at 2560 BC, stood at 146.5 meters and was tallest man-made structure in the world for the over 3,800 years, more than 3,800 years. And Burj Khalifa at an astonishing height of 829.8 meters in Dubai is the current tallest man-made structure, right? So these are the world largest, world one at Mumbai. So the structure, skyscrapers at Mumbai. It is not the world tallest. It is named as World One Mumbai. Expensive land pricing. There you have expensive land pricing. So here there is in the Mumbai the square centimeter becoming huge cost. And that's why you need to take a structure like this in the economic status of the city, and to enhance or to showcase the economic status of the city, you need to construct such a skyscrapers, military surveillance and broadcasting for the telecasting purposes, right? Structural components. And here there will be a two category of structure: substructure and superstructure. Substructure is a portion below the ground which transmits the entire load to the soil. So the total load will be transferred via the foundation, or this will be called as substructure. And in this case, superstructure, it is a portion of the structure above the ground level. Whatever may be the height from the ground level will be considered as superstructure. So mat or raft foundations. So here we will explain about the various foundation system. What we usually doing for nowadays in houses will be considered as pile foundation, and this one is the pile foundation. You need to dig a drill like arrangements, or what we can say that square like digging of just a minute. So this type of structural excavation you need to do in earth, and then you need to fill that excavation with steel and concrete mix. So that is your concrete structure that will be considered as pile, and over the pile you need to connecting those piles. You construct a beam or like that, and then over that you can start a common beam, or else you can construct the building. So this will be considered as pile foundation. And another one is deep foundation, which we construct under the sea. We will consider as deep foundation. And there is a mat foundation where in the clay soil areas and other things we need to go for a complete mat-like structure on the earth, and then over that you need to construct a earth beam, connecting beams, and then over that you can construct a building. So fire foundation, it's another class of foundation which we do for the bridges and other things. You just go through the Google through these terminologies: what is pile foundation, what is fire foundation, what is raft, and what is deep foundation, all those things, right? Just to create an understanding. Superstructures. So this we already discussed. Whatever the structure above the ground will be considered as superstructures. Load bearing structural part. This transmits the dead load and live load to the foundation. So already we discussed what is the dead load and what is live load. Live load is nothing but whatever the things we are keeping over the building, or whatever the human being occupying the building will be considered as live load. And dead load is because of the structural material, that is construction materials, and also like ice formation or dust formation or wind formation, like that. Whatever things we can consider as dead loads. Similarly, the superstructure, there will be a load-bearing structure and non-load-bearing structure. So, load-bearing structure will carry all the dead load and live load, whereas in the non-load-bearing structure, it does not carry load but perform the functions of partition walls. So, for the purpose of privacy, for the purpose of illumination or ventilation, like that. And shear wall, steel frame, tube frame, trusses, tube, and expressing all these things will be considered as one form of non-load bearing structures, right? Non-structural components. So these are the various terminologies we need to familiarize with respect to the civil engineering. So here the non-structural components, one among that is elevators. It is necessary in the skyscrapers to transport people and goods to the different floors. Taller the building, more elevators are needed. Placement of elevators need to be properly planned and designed to maximize the profitability of the skyscraper. So another thing is escalators, and it is used to transfer the people at the lower levels between the lobbies and the upper lobbies. So it is not for the huge height, it is maybe for the 10 to 20 feet. And the elevators, escalators should be situated where they can easily seen by the general public. Another is building orientation. So here the orientation is very important to make the skyscraper energy efficient and enjoy the gift of the nature. That means your building structure should be aligned with a natural lighting system and natural wind movement system. So in such a way you need to design, so that will maybe you can call it as Vastu Shastra, and based on that if you construct, and you will get the building proper orientation where you can minimize the electrical light load as well as cooling loads, as well as you can reduce the other evacuation loads, or maybe other fan light loads, other things, right? So the skyscraper safety is very much important. So design of skyscrapers is of prime importance to make it as safe and stable against the loads acting on it. Fire safety and management plans are needed to minimize the dangers on the lives. There should be egress planned for evacuation in case of emergency. So the emergency exit should be planned accordingly. And advantages, this is a multi-purpose building where you can make it as residential purpose, commercial or institutional or anything. Space, it increases the total floor area, and it best suited where the land prices are expensive. And views, it provides a long range view in the congested city where you can attract the tourists and other things. And symbolisms, it gives the symbol of the country or state for wealth, power and history. And also broadcasting, it provides excellent site for installing broadcasting equipment, that is like TV channel offices and other things. Disadvantages, safety is prime thing. 100% safety cannot be achieved in the skyscrapers. So I hope you can remember the September 11th incident. So defective towers may pose a risk of falling and cause severe damages. The occupants at high floor level gets difficult in evacuation during the emergency. The cost of construction is very high, and the environmental impact is also there. The pollution increases as lots of material like steel, cement, etc. are used in the construction. Noise pollution due to large number of people and automobiles. And psychological impact, the old age people and children will have psychological impact in living at a high height. So these are the disadvantages. Remaining things we will discuss in the further video. Thank you for watching.